5.8. Number 1 was about insect population that's growing according to this model, and it said how much was there, how many insects were there at time 0? Well, that's the starting amount, 500. What's the growth rate? Well, that's e to the 0.02, which is 1.02. So it grows by 2%, 20, grows by 2% per year. The growth factor is 1.02, but it's growing by 2%. And that's what this says right here anyway. It grows by 2%. And how much is there after 10 years? So we'd put 10 in here. So we're going to have 500 e to the 0.02 t, which they said 10 years. So make sure I put those in parentheses when I type it in. So I'm going to have 500 e to the 0.02 times 10, and I get 610.7 is going to be the population. It's gone from 500 to 610 after 10 days, I should say. We're supposed to find out how much, when would it take to get 800. So we're going to have 800 equals 500 e to the 0.02 t, which is days. So divide by the 500 first. We're going to get 8/5 equals e to the 0.02 t. Then write it as a log equation. So this is going to be base e. So to what power do we take 8 e to get 8 divided by 5? 1.6. And that's 0.02 t. So we're going to divide both sides, 0.02, 0.02. And so ln 8 divided by 5, close parentheses, divided by 0.02 is 23.5 days. That's how long it takes to get to 800. To double, that's going to be 1,000, 500 to 1,000, but we know that that just means this part has to be 2. So I'm going to write 2 to stand for doubling equals e to the, and that's what I would get if I put 1,000, 5,000 divided by 500 is 2, e to the 0.02 t. Write it as a log equation. ln2 equals 0.02 t, and divide by 0.02, so I got ln2 close parenthesis divided by 0.02, and I get 34.7. Doubles in 34.7 days. And the final one I'm going to do is the pizza problem that they had, which requires you to have Newton's cooling formula. And it says the temperature after a while is equal to the temperature you take it out of the oven plus the room temperature minus the temperature you take it out of the oven, e to some kT. Okay? And so it says 1 will be 135. So this equation is going to look like the temperature after a while, after some time. In this case, it's T is in minutes. The oven temperature was 450 plus room temperature was 70 Oh, wait a minute. I gotta check that. T is the constant temperature of the room. So I got the 70 and the 450 wrong place. I thought so. We got a minus here. Temperature of the room, temperature of the oven, 450. Let me write this again here. The temperature of the pizza is, the temperature it will be the 70 degrees plus the temperature of the oven, 450, minus 70, the room temperature, e to the k, and they said after 5 minutes, I put t here, but I'm going to put 5, and it was down to 300. So I'm going to solve for the k. I'm going to subtract 70. That'd be 230. And 70 from 450 is 380. And then I'm going to divide by 380. So 230 divided by 380 is 0.605 equals e to the kt to k5. Change it to a log equation because the unknown's in the power, the constant. So I'm going to write ln, because it's base e, of 0.605. To what power do I take e to get 605? And that's k times 5. And so I divide by 5 to get k. So the k for this situation in the pizza is going to be always ln 0.605 close parenthesis divided by 5, works out to be negative 0.1005. So now it asks, when will it be 135? So instead of putting 300 there, we'd put 135 equals 70 plus, and the 450 minus 70 was 380. E to the k, which is negative 0.1005 times the number of minutes time. So we'd subtract 70, which would be 65. I'm running out of room here, so I'm going to jump over on a new page. I'm going to have 135 equals 70 plus 380 e to the negative 0.1005 t. Subtract 70 and I get 65 equals 380 e to the negative 0.1005 t. Divide by 380. And I get 0.171 equals e to the negative 0.1005 t. Unknowns in the log power, this base e, so ln of 0.171 equals negative 0.1005 t. Divide by this constant. And the time it takes to get to 135 will be ln of that last answer I had there divided by negative 1005. And it'll take 17.5.6 minutes. Okay? And part C said, what's this approach? Well, this is an exponential that's moved up 70 and it's flipped around whatever, but that makes the horizontal asymptote 70, and so this curve would eventually approach 70 degrees, the room temperature, and that's what they're trying to get you to see. All right.